Licensing classifications for electricians vary from state to state. In general, there are three main classifications. Firstly, journeyman electrician, secondly, master electrician, and thirdly, contractor. A journeyman electrician is authorized to perform electrical work under the supervision of a licensed master electrician. A master electrician is authorized to supervise and direct electrical work, design and install electrical systems, and sign off on electrical permits. A contractor is authorized to own and operate an electrical contracting business. In Ohio, the National Master Electrician's Exam is the required exam to obtain a master electrician license. This license allows an individual to perform electrical work independently, supervise others, and sign off on electrical permits. In the context of a non-union shop, the terms licensed master electrician and licensed contractor are often used interchangeably. In this case, both refer to an individual who has obtained a master electrician license and is authorized to operate an electrical contracting business. In a union shop, there may be more distinct classifications within each license type. For example, a licensed master electrician may be able to supervise a certain number of journeymen, while a licensed contractor may have additional responsibilities such as procurement and bidding. Passing the National Master Electrician's Exam in Ohio grants an individual a master electrician license, which authorizes them to perform electrical work independently, supervise others, and sign off on electrical permits. This license is equivalent to both a licensed master electrician and a licensed contractor for non-union operations. Now let's delve deeper into the nuances of these classifications and what they entail. The journeyman electrician classification is the entry point for many into the electrical trade. After completing an apprenticeship or equivalent training program, an electrician typically becomes a journeyman. This classification signifies that they have the necessary skills and knowledge to perform electrical work safely and competently, but they must do so under the guidance and supervision of a licensed master electrician. This supervision ensures that the work is performed according to code and industry standards, minimizing the risk of errors or hazards. The master electrician classification represents a significant step up from the journeyman level. Master electricians possess a higher level of expertise and experience, allowing them to take on more complex and challenging electrical projects. They are authorized to design and install electrical systems, which involves understanding electrical codes, calculating loads, and selecting appropriate materials and equipment. Master electricians also have the responsibility of supervising and directing the work of journeyman electricians, ensuring that all work is performed safely and up to code. In addition, master electricians are typically authorized to sign off on electrical permits, which are required for many types of electrical work. This means that they are responsible for ensuring that the work meets all applicable codes and regulations before it is approved by the local authorities. The contractor classification is different from the other two in that it focuses on the business aspects of the electrical trade. An electrical contractor is authorized to own and operate an electrical contracting business, which involves managing employees, bidding on projects, and ensuring that the business is profitable. In some jurisdictions, a contractor may also be required to hold a master electrician license, while in others, they may be able to employ a master electrician to oversee the technical aspects of the work. Now let's turn our attention to the specific requirements for obtaining a master electrician license in Ohio. As mentioned earlier, the National Master Electrician's Exam is the required exam for this license. This exam covers a wide range of topics related to electrical theory, codes, and practices. To be eligible to take the exam, an individual typically needs to have several years of experience working as a journeyman electrician. Once an individual passes the exam, they are granted a master electrician license, which allows them to perform electrical work independently, supervise others, and sign off on electrical permits. It's important to note that the requirements for obtaining an electrician license can vary significantly from state to state. Some states may have more stringent requirements than others, while some may not even require a license at all. Therefore, it's essential to check with the local licensing board to determine the specific requirements in a particular jurisdiction. Now let's address the question of whether the terms licensed master electrician and licensed contractor are interchangeable. In the context of a non-union shop, these terms are often used interchangeably, as both refer to an individual who has obtained a master electrician license and is authorized to operate an electrical contracting business. However, in a union shop, there may be more distinct classifications within each license type. For example, a licensed master electrician may be able to supervise a certain number of journeymen, while a licensed contractor may have additional responsibilities such as procurement and bidding. This distinction arises from the different organizational structures and collective bargaining agreements that are common in union shops. Union shops typically have more defined roles and responsibilities for each position, which can lead to more specialized classifications within each license type. Non-union shops, on the other hand, tend to have a more flexible organizational structure which allows individuals to take on a wider range of responsibilities. Ultimately, the specific requirements and classifications for electricians will depend on the jurisdiction and the type of shop in which they work. However, the basic principles of electrical safety and code compliance remain the same, regardless of the specific classification or organizational structure. Now let us dive a bit more into the responsibilities of each classification, starting with the journeyman electrician. The journeyman electrician's primary responsibility is to install and maintain electrical systems under the supervision of a master electrician. This includes tasks such as running conduit, pulling wire, installing outlets and switches, and connecting electrical equipment. Journeyman electricians must be familiar with the National Electrical Code, also known as NEC, and other applicable codes and regulations. They must also be able to read and interpret blueprints and electrical schematics. In addition to technical skills, journeyman electricians must also possess strong problem-solving and communication skills. They must be able to troubleshoot electrical problems and communicate effectively with their supervisors and coworkers. They must also be able to work safely and efficiently, following all safety protocols and procedures. Master electricians have a broader range of responsibilities than journeyman electricians. In addition to installing and maintaining electrical systems, master electricians are also responsible for designing electrical systems, obtaining permits, and supervising the work of journeyman electricians. Master electricians must have a thorough understanding of the NEC and other applicable codes and regulations. They must also be able to perform complex calculations and design electrical systems that meet the specific needs of a project. In addition to technical skills, master electricians must also possess strong leadership and management skills. They must be able to effectively supervise and motivate their crews, ensuring that all work is performed safely and up to code. They must also be able to manage budgets, schedules, and other resources. Electrical contractors have the broadest range of responsibilities of the three classifications. In addition to the responsibilities of a master electrician, electrical contractors are also responsible for managing the business aspects of an electrical contracting company. This includes tasks such as bidding on projects, managing finances, and marketing the company's services. Electrical contractors must have a strong understanding of business principles, as well as technical knowledge of electrical systems. They must also be able to effectively manage employees, subcontractors, and other resources. In addition to the technical and business aspects of the electrical trade, all three classifications must also possess strong ethical and professional standards. Electricians have a responsibility to protect the safety and well-being of the public. They must perform their work with integrity and honesty, following all applicable codes and regulations. They must also be committed to continuing education and professional development, staying up to date on the latest technologies and best practices. To further clarify the differences between union and non-union environments, let's explore some specific examples. In a union setting, a journeyman electrician may have specific wage rates, benefits, and working conditions that are negotiated through a collective bargaining agreement. They may also have opportunities for apprenticeship training and continuing education through the union. A master electrician in a union setting may have additional responsibilities, such as serving as a foreman or supervisor on large projects. They may also have opportunities to participate in union leadership and decision-making. An electrical contractor in a union setting may be required to use union labor on all projects. They may also be required to contribute to union benefit funds such as health insurance and retirement plans. In a non-union setting, a journeyman electrician may have more flexibility in terms of wage rates and working conditions. However, they may also have less job security and fewer benefits. A master electrician in a non-union setting may have more autonomy in terms of decision-making and project management. However, they may also have more responsibility for ensuring that all work is performed safely and up to code. An electrical contractor in a non-union setting may have more flexibility in terms of hiring and managing employees. However, they may also have more difficulty competing with union contractors for large projects. Regarding electrical safety, it is paramount that all electricians, regardless of their classification, adhere to stringent safety protocols to prevent electrical accidents and injuries. These protocols include energizing circuits before working on them, using appropriate personal protective equipment such as gloves and eye protection, and following lockout-tagout procedures to prevent accidental energization of circuits. Electricians must also be aware of the hazards associated with working near energized equipment, such as arc flash and electrocution. They must be trained in safe work practices and procedures, and they must be able to recognize and avoid potential hazards. Now let's discuss some common electrical code requirements that all electricians should be familiar with. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Electricians must be familiar with the NEC requirements that apply to the specific type of work they are performing. For example, electricians who are installing wiring in a residential building must be familiar with the NEC requirements for residential wiring. Electricians who are installing wiring in a commercial building must be familiar with the NEC requirements for commercial wiring. The NEC is updated every 3 years, so it is important for electricians to stay up to date on the latest code changes. Electricians can stay up to date on the NEC by attending training courses, reading industry publications, and consulting with code experts. Regarding specific code requirements, grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Bonding connects all metal parts of an electrical system together, which helps to equalize the voltage potential and prevent electrical shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are designed to trip and interrupt the flow of current when the current exceeds a safe level. Wiring methods refer to the types of wiring that are used to install electrical circuits. Common wiring methods include conduit, cable, and open wiring. Each wiring method has its own advantages and disadvantages, and the appropriate wiring method will depend on the specific application. Equipment installation refers to the way that electrical equipment is installed. The electrical equipment must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. Now let's consider some practical examples of how these licensing classifications and code requirements apply in real-world situations. Imagine a homeowner wants to add a new circuit to their electrical panel to power a new appliance. They would typically need to hire a licensed electrician to perform this work. The electrician would first need to assess the existing electrical system to determine if it can handle the additional load. They would then need to install the new circuit following all applicable codes and regulations. The electrician would also need to obtain a permit from the local building department before starting the work. Once the work is completed, the electrician would need to inspect the work to ensure that it meets all code requirements. Now imagine a business owner wants to install a new lighting system in their office building. They would typically need to hire a licensed electrical contractor to perform this work. The electrical contractor would first need to design a new lighting system, taking into account the lighting needs of the office space and all applicable codes and regulations. They would then need to install the new lighting system, following all safety protocols and procedures. The electrical contractor would also need to manage the project, ensuring that it is completed on time and within budget. Now, regarding voltage and amperage, let's discuss the common voltage levels found in residential and commercial buildings in North America. In residential buildings, the most common voltage levels are 120 volts and 240 volts. 120 volts is typically used for lighting small appliances and receptacles. 240 volts is typically used for large appliances such as electric stoves, clothes dryers, and water heaters. In commercial buildings, the most common voltage levels are 120 volts, 208 volts, 277 volts, and 480 volts. 120 volts is typically used for lighting small appliances and receptacles. 208 volts is typically used for HVAC equipment such as air conditioners and heaters. 277 volts is typically used for lighting in large commercial spaces. 480 volts is typically used for large industrial equipment such as motors and pumps. Amperage is a measure of the amount of electrical current flowing through a circuit. The amperage rating of a circuit breaker or fuse indicates the maximum amount of current that the circuit can safely handle. If the current exceeds the amperage rating of the circuit breaker or fuse, the device will trip and interrupt the flow of current. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation method. These tables are used to ensure that conductors are not overloaded, which can lead to overheating and fires. When working with electrical systems, it is essential to use appropriate test equipment to verify that circuits are de-energized and to measure voltage, current, and resistance. Common test equipment includes voltage testers, multimeters, and clamp-on ammeters. Voltage testers are used to verify that a circuit is de-energized before working on it. Multimeters are used to measure voltage, current, and resistance. Clamp-on ammeters are used to measure current without having to interrupt the circuit. It is important to use test equipment that is properly rated for the voltage and current levels being measured. It is also important to follow all safety precautions when using test equipment. Now let's briefly touch upon grounding electrode systems. A grounding electrode system is a system of interconnected electrodes that are used to provide a low impedance path to ground. The grounding electrode system is typically connected to the building's metal water pipe, metal frame, and ground rod. The grounding electrode system helps to protect people and equipment from electrical shock by providing a path for fault current to flow back to the source. The NEC specifies the requirements for grounding electrode systems, including the type and size of electrodes, the methods of installation, and the bonding requirements. Maintaining an up-to-date knowledge of the NEC is paramount for all licensed electricians. The NEC is a comprehensive document that covers a wide range of electrical safety topics. It is updated every 3 years to reflect changes in technology and best practices. Electricians can stay up to date on the NEC by attending training courses, reading industry publications, and consulting with code experts. Many organizations offer training courses on the NEC, including the National Fire Protection Association, the International Association of Electrical Inspectors, and various trade schools and community colleges. These courses can help electricians to understand the NEC requirements and how to apply them in their work. Industry publications such as Electrical Construction and Maintenance Magazine and Electrical Contractor Magazine provide articles and information on the NEC and other electrical safety topics. These publications can help electricians to stay up to date on the latest code changes and best practices. Consulting with code experts can be a valuable resource for electricians who have questions about the NEC. Code experts can provide guidance on how to interpret the NEC requirements and how to apply them in specific situations. In conclusion, understanding the nuances of electrician licensing classifications is crucial for both individuals seeking to enter the electrical trade and for those who are already working in the field. The specific requirements and classifications may vary from state to state and between union and non-union environments, but the fundamental principles of electrical safety and code compliance remain the same. By staying informed about the latest codes, best practices, and safety protocols, electricians can ensure that they are providing safe and reliable electrical services to their customers and protecting the public from electrical hazards. Therefore, remember always to consult the relevant electrical codes and licensing boards to ensure you are meeting the local requirements, and remember that your duty is to provide electrical services that are safe to the public.